like to welcome to this presentation of the activities of the Fire Research Center of the University of Coimbra. This will be a quick overview of our activities and our assets. Of course, one of the main assets of our group is the people, are the people that compose our team that will be knowing during this presentation as well, and also the equipment. One of the main assets that we have is our Fire Research Laboratory that will be the main object of this presentation. Our project, research program, started 25 years ago, and its main aim has been to understand how fire behaves in order to contribute to improve the safety of the people that have to deal with fires. Inside this laboratory that has been built in several stages, and at this moment when I'm talking to you, it is being increased, it is being made larger. We have different devices that have helped us to understand better how fire behaves, and especially to understand better the role of wind and topography on fire spread. This laboratory is used to train firefighters, Portuguese firefighters, and to help them to understand how sometimes conditions can be very dangerous for them. And it is open to anyone who wants to use it and to cooperate with us in this work of better understanding forest fires and to know how to cope with them and manage them with more safety.
The head office of ADAI is in Coimbra. In this place there is a small research laboratory where some experiments about forest fires can be made. The main laboratory of CEIF is the Forest Fire Research Laboratory that is placed in Lusa since 1999. Here it can be found larger research structures such as combustion winds, tunnels and combustion tables. Some of these structures are unique in the world and were specially designed and built under supervision of ADAI and dedicated to the study of the effect of the wind and slope in the spread of forest fires, as well as the understanding of spot fires. For over 20 years, CEIF maintains a program for determine moisture content of finest fuels representative of the fuel cover in central Portugal. This data is, in summer months, on a daily basis transmitted to the local fire authorities and used for support in fire combat decisions. The ability to estimate accurately the moisture content of forest fuels is determined for predicting fire risk and potential fire behavior. Therefore, CEIF has made efforts in this area of investigation using advanced equipment for the determination of equilibrium moisture content and response time of dead fine forest fuels and its use in prediction models. When we prepare fuel beds with a given fuel load on dry basis, the first step is to determine the fuel moisture content. This is usually done by taking a small fuel sample and using a fuel moisture analyzer that will retrieve an accurate value in around 10 minutes. After determining the amount of fuel that is needed, the fuel is weighted and afterwards spread homogeneously on the test rig. Although in the nature, forest fires rarely spread in the absence of wind or slope, the knowledge of the basic rate of spread in those conditions is useful, serving as a reference value. The images of the experiments are usually registered as photos, video images and infrared images. With the platform lift, it is possible to register the images at any viewing angle. In given conditions, forest fires can increase their rate of spread up to more than 100 times in a period of time as short as a few minutes. In the field, this incubation time is generally of order of 15 minutes. We designate this type of fire an eruptive fire, and in these situations fires tend to form a convection column that resembles the eruption of a volcano. Canyons are prone to cause this phenomenon. Systematic studies from our research team show that topography alone is enough for causing this dramatic increase in the fire intensity and rate of spread. Unfortunately, in many cases these fires cause fatal victims. Scale and border effects can sometimes hinder the extrapolation of the assessments of fire behavior made from the laboratory experiments to real fires. For that reason, most of our test rigs have considerable dimensions, increasing the similarity between test fires and forest fires. test rig in particular is frequently used for simulating fatal accidents that result from fire spread in canyons. Most of the more tragic accidents known worldwide resulting from forest fires took place under these circumstances. This is the case of Mud Gulch, Loop and South Canyon accidents in the US and Guadalajara accident in Spain. Each of these accidents caused the loss of more than 10 lives. Changes in topography can originate considerable differences in fire behavior. For that reason, it is of great interest to study fire spread and the slope transitions. In our laboratory, we can perform these studies in the diagonal table. Wind, along with topography and fuel properties, is one of the most influent parameters on the fire behavior. In this combustion tunnel, the wind speed can vary continuously up to around 20 kilometers, and its effect of the spread of fire in various fuel beds can be studied. In most situations, fire spreads under the combined effects of wind and slope. Using this test rig, we can study several combinations of slope angles and wind speeds. The time that each particle inside the fuel bed takes to ignite has considerable influence in the fire rate of spread. Using this device, we can measure the time delay to ignition of fuel particles and relate it, for example, with the moisture contained. Spot fires are a very dangerous form of fire spread. In order to improve the knowledge of this very complex process, we started a systematic research of the various phases of amber formation, transport and landing. In this test rig, we can burn entire trees and register the mass loss of the tree and the particles emitted during the test. Using an advanced particle image velocimetry, we can characterize the properties of these particles, namely their number, size, shape and velocity. In our vertical combustion tunnel, we can study systematically the properties of potential embers in a vertical flow of variable velocity. For example, we can measure the mass loss rate during the flight of a burning particle in a wide range of experimental conditions. The oblique combustion tunnel is an original equipment that allows us to extend the studies of combustion of potential embers to flows of arbitrary orientations and velocities. We can also measure the aerodynamic properties of particles that can be potential embers. The occurrence of spot fires depends on several factors such as the reception fuel moisture content and if the firebrands are flaming or glowing. By stimulating the landing of flaming or glowing firebrands on several fuel beds, we can model the probability of ignition as a function of the ambient conditions. In the context of a protocol with a fire brigade training school, our laboratory is used to train Portuguese firefighters in topics associated to fire behavior and fire safety. We receive visits of hundreds of firefighters from all over the country and also of scientists and students from various parts of the world. We have developed a consistent program of performing field experiments that has been carried out since 1986. During these recent years, we have made these tests in the area of Gestosa in the Lousa mountain. We burn pre-prepared plots of shrub vegetation in slopes to analyze fire behavior, but also several other aspects related to fire management. These experiments are always performed with the support of firefighters that assure the safety of the experiments. Researchers from various countries inside and outside Europe also used to participate in these field experiments.